Hello everyone and welcome to my YouTube channel. Today's topic is factorization of algebraic expressions. So let's start factorization of different expressions. AB plus 4A plus 3B plus 12. So now you are given an expression and you have to find out the factors of this one. You have to put them in a form which is a factor of 2 or 3 terms. So you have to look at the whole expression. The expression is containing four terms: AB, 4A, 3B, and 12. So the easy way would be to write the factors of each term. So this is A and B. The factors of this one is 4 and A. And you can see the factors of this one is 3 and B. And the factor of this one is 3 into 2 into 2. Right? Now we can see that we have something common in this one and something common in this one. We can see that A is common in these two. So nothing is, for the first thing you have to do is check if there is anything common in all of them. So A is common in these two but not here. B is common in these two but not here. 4 is common, 4 is here and here but not in the rest of the two. 3 is in these two and not in these. So you have to make pairs. So in this one we can see that we have A in here and in here, right? So I can write down, I can take out A is common, right? And here what is left? Well, if I take out A from here, I am left with B. And then there is a plus sign, and here we took A from here, so what is left is 4. Now you write down a plus sign, and now look for the common term in this and in this. So you can see 3 is in both of them. So I take 3 out. What is left here? B plus what is left here? 4. Now you can see you have again 2 terms. So there were 4 terms, we made 2 terms out of it, and now we can see that in these 2 terms, this term and this term, they are both the same. So we can take this term out. So what is left in the factors of these two? So you have the factor A and this term, 3 and this term. So if you take out this term, in here from these two factors, which one is left? A is left. And from these two, which one is left? 3 is left. So it means you can write this down as B plus 4 and A plus 3 are the factors. When they were expanded, they gave us this thing. So if you are given an expanded form and they're asking you to find out the factors, this is how we do it. And we already know that if you are given the factors, how do you expand them to get this one? So you can see that if you go from down up, you would see that this is the exact same procedure that you did with this one, that you multiply this and this and this, and then you multiply this into this. So I hope you understand how you can factorize these expressions. Let's go to a different one. Okay, so let's do this one. 2ab whole square is a little bit different, so it's good to do this one. Now you can again factorize it. It's very simple. So we can write this down into a plus 2b and then minus a plus 2b and 3a minus 7b. We can see that this one and this one, they are the same. So we can take that out as a common term. And here we are left with a plus 2b, a negative sign, and 3a minus 7b. When there is, remember, when there is a negative involved, do not do it straight away, right? Write down the negative and follow the steps. Otherwise, you would have trouble with these signs. So a plus 2b, here a plus 2b. Now this minus will multiply to 3a, this becomes minus 3a, and this minus will multiply to minus 7b, that becomes plus 7b. And then you can write this as a plus 2b, and then you have a and minus 3a, that gives you minus 2a, and then you have 2b plus 7b, that gives you 9b. So these are the two factors, and they were expanded to give you this. Now factorization, but with the identities, right? Or the algebraic identities that we have learned was that a plus b whole square was equals to a square plus 2ab plus b square, or the other way around, a minus b whole square is equals to a square minus 2ab plus b square, and a square minus b square was equals to, or the other way around, a plus b into a minus b was equals to a square minus b square. So we have to use these and factorize some of the expressions. So one of the expression is k square minus 81. Now we can see that this is the k square, and 81 is a square of something, and that something is what? Is 9. So k can be written as k square, and 81 can be written as a square of 9. And now you can see, we can compare this with any of these three, and we can see that this one is comparable with this one. So we have a is k and our b is 9. So according to the formula, if you write this one, this form into this form, it would be a, which is k, plus b, which is 9, a, which is k, minus b, which is 9. So the factors of this one are these two. Similarly, you can do one more, and let's do this one, is minus 4 s square and plus 121, right? So we can write this as 121 minus 4 h square. This can be written as 121 is a square of 11, and minus 4 is a square of 2, and h, so 2h whole square is 4h square. Now you can again compare it with this one. So that would be 11 plus 2h and 11 minus 2h. Let's do a different example. I was looking for a different one Okay, so let's do this one. X square minus 8x plus 16. So we can see that this is a square of x. We can see that 16 is a square of 4, right? So when we have the square of x and the square of a and the square of b, and then there is this term, we can see that this is either of these two identities. So if there is a negative, it means it is this identity, and in this identity we have minus 2 times the first and the second. So minus 2 times what is our first is x and our second is 4. Now see whether this gives you that minus 8. So that is 2 times 4 is 8x, so that becomes 8x, and that is minus 8x. So now this is comparable with this formula, and it says that this can be written as the first minus the second whole square, or you can write this as first minus and again, so 2 times. The same would go if there was a plus, then we will compare that with this one, right? And then there will be a plus here, and according to the rules of that identity, there will be a plus, there will be a plus, and there will be a plus. So if you are given such type of problems, and you can factorize them using these identities. Evaluate this one, 69 times 83 using factorization, right? So this is one term, this is another term. We can see that there is something common in both of them, in here and in here. What is that number? That is 83. So if we take out 83 from here, we are left with 79, and then there is a negative sign, and if you take 83 from here, what is left is 69. So we can see that 79 minus 69 gives us 10, so that is 830. And the next one, if they are giving you any of problems of this type, that is a square, then you can write down again 103 whole square minus 3 square, and this you can compare using this one. So that would be 103 plus 3 and 103 minus 3. So I hope you understand how to factorize using these identities, and and you are able to factorize it without these identities. Thank you very much.